Hi everyone, good morning. Thank you for coming to my session. I'm going to talk about the SQL Server versus Cosmos DB in this session. And just like an FYI, I'm not trying to, compete those two products. They are two great products, but that's the most common question usually I get in any kind of conferences. Which one should I use? A new project is coming up, and it's really not an easy question to answer. Without all the details. So what I'm going to actually do in this session is, I'm going to try to give you all the details and compare these two great products so you can make a better decision for that question. Before I go in, let me actually speak about myself. My name is Hasan Savran, and I am from Cleveland, Ohio, United States, and I'm a Cosmos DB MVP, well, Microsoft MVP for 4 years. I'm proud and honored to be the part of the program. And I developed the Cosmos DB SQL Studio. Do you use that? Do I have any users here? If not, it's an VS Code extension. You can download it for free, and you can actually query the Cosmos DB by using that. And rather than that, I have my blog. You can try to look at it. Mostly I write about the Cosmos DB, SQL Server, C# front end. Whatever I know, I try to share it there. And if you will have any questions that I cannot answer here because of the time limits, you can always connect me from the LinkedIn or the Twitter, and I'll be more than happy to answer any of your questions and help you from there. So let's actually start with looking at the centralized databases. Centralized database, well, SQL Server is one of them. So in centralized databases, we have clients. You might have a Tableau report, you might have a Power BI report, you might have SSMS trying to connect and get the data from the SQL Server. Well, those clients, they don't really need to think about where the data is coming from. As long as you have the connection string, you just send a request, and all magic actually happens in SQL Server, and you just get the data back. So most of the, the conferences like that, you try to learn how can I make the central database faster by, creating indexes, partitioning, this and that. So, and also, whenever, rather than finding the data, sorting the data usually happens in central databases. If you need to do any kind of aggregation, minimum, maximum, average, all those actually happens in central databases. So there's a lot of pressure on the central databases because of that. You might have a query, maybe it runs like 2 seconds, but if you have concurrent users, 50, 100 in the same time, well, central databases can be the bottleneck very quickly. So there are some challenges with the central databases. So if we actually look at the Cosmos DB works totally different. So right now, we have your data is actually getting distributed. So it's not in a central place anymore. That's not the replication of the same data. So your data is all over the place. So if you have any of the clients here in the bottom, and let's say we have a web application, and the web application is trying to run something really simple query. We are going to look at, let's say we are saving the orders. So our orders are all over the place. And I'm looking the orders top 10 for New York. Well, that's where actually, things getting tricky in Cosmos DB. So first of all, we kind of need to figure out what the partition key is. If the partition key is the city, then that means that Cosmos DB know exactly where the data is. If the partition key is not the city, then that means that we are going to run that query in every database we have out there, which means that it's going to cost us, more money because it's going to use memory, it's going to use CPU, and it's going to use all kind of resources that we really don't have to. That's where when the people say that Cosmos DB is an expensive database, but if you don't pick the right partition key, Cosmos DB has to be an expensive database because you are running that in every physical partitions. So when we talk about the physical partitions, let's compare that first. So in SQL Server, when you do the partitioning, usually you do that when your table gets really large. When the table gets really large, well, it takes more time for SQL Server to actually seek the data. So just like a regular, if you are going to ask somebody to get the salt from this one to the other side, it's going to take some time to actually bring the salt to the other side. So to fix that problem in SQL Server, what we do is we do the partitioning. So we make this huge table, small tables. And usually you do that by dates. So you put the sum of the date in 2010, 2011, 2012, as long as you have the year in your query. Now SQL Server has to go only in that small table to look for the data. So that's why things go much faster. The good part is the user doesn't see all those tables. Users still see one table. And the schema is exactly the same. So we really distribute the data, but in file level in SQL Server. In Cosmos DB, the idea is same, but scaling is totally different. So what you see here is this is a physical partition of a Cosmos DB. And this is managed by Microsoft totally, so there's nothing you can really change here. But I guess the things need to know about this one is we have 4 computers in one physical partition. It's a replica set. We have a leader and 3 followers. All the updates, deletes, whenever you need to change the data, it goes to the leader, and leader syncs with the followers. So this picture kind of really tells you why Cosmos DB is really fast. Because if you are a web application, you try to pull the data, well, depending on your consistency level you pick, you have 4 places to get that data from, not just one, like centralized database. So as I said before, you cannot change anything here, but there are 2 numbers here that you really need to know by your heart. The first one is the storage limit. One physical partition can deliver only 50 gig data. If you are going to pass 50 gig data, then that means you're going to have another physical partition. That means you're going to end up with 8 computers. And also the 10,000 request units per second. So you might have only 30 gig data, but your web applications maybe is very busy. So you might need more than 10,000 request units. That will trigger another physical partition for that. So you kind of need to know those 2 numbers. By knowing them and what you need, you can kind of guess how many physical partitions you are going to end up with. And in physical partitions, we are going to have logical partitions. In each physical partition, you are going to have 2 hash numbers, minimum hash number and a maximum hash number. And by just knowing the hash number, Cosmos DB actually can tell which physical partition has which data. So if we look at that example here, let's say we have orders and we are saving that, and our partition key is customer ID. Now, let's say we have 4 physical partitions. By just looking at that, I'm guessing we have data between 150 to 200 gig, or this is pretty busy application, and we have 30,000 plus request units per second by just looking at this number. As you can see, there's a hash number in each of them, and it starts from 0 and it ends by FF. Every time you actually have a new physical partition, those hashes are getting divided, and each of them hash number might change. So in each blue box here, you see, those are the logical partitions, which you define when you actually define your orders. So that's the partition key I said, customer ID. So each of those blue boxes are really customers, and all the data goes in that box. For example, let's say we are going to try to insert data, right? And let's say our customer ID is John 1234. The first thing Cosmos DB is going to do is hash that partition key. And that partition key is going to be somewhere between 0 and FF after it hashed. From that point, it's going to know which physical partition should have this data. And from here, it's going to write exactly that physical partition. So that's how the write is going to actually work. If you are going to try to select the data, well, it's going to do the same exact thing. So it's going to first, well, we are hoping John 1234 is in our where clause, because if it is, then we are going to know exactly which physical partition is going to have the data. As long as it's there, then we are going to go and pull, let's say it's in the 3rd one, it's going to just go to the 3rd one and pull the data only from there. So we are going to use only CPU, memory, for only that physical partition. If you don't have John 1234 in your where clause, well, we have no option but send this select statement to every physical partition, which is going to be cost much more than running in one. Next one I'm going to cover is the query plane. So that's one of the questions usually I ask in actually interviews. I ask the people, okay, you have this select statement in your SSMS. You click to execute, and you see the data. How did that happen? What happens in the middle? So in SQL Server, first, SQL Server is going to check your T-SQL, be sure that everything is written fine, and it's going to bind all the objects you have in the select statement. It's going to find the tables. If you use any stored procedures, columns, it's going to figure out that all those exist actually in SQL Server. From there, it's going to go to the query optimization. Query optimization is going to look at all the indexes, all the statistics, the size of the tables, and it's going to try to find different ways to actually deliver this data to you. And it's going to create many query plans by doing that. Since we can kind of guess the CPU, I/O, you can kind of look at how much each of them is going to cost to SQL Server. So SQL Server at the end can go back and find the cheapest one and use that to actually deliver the data. From that point, it will cache your plan. So if you're going to run that again, it doesn't have to do all those extra work. So everything is cached. Now, this is pretty clear, close to Cosmos DB. If you look at the Cosmos DB, let's say we are going to run exactly the same select statement here. Parse and bind is going to be not that much because in Cosmos DB, we don't have a schema. So there's not that much to check. There are some to check, but there's not as much as SQL Server. The next one is a very important one. We have to generate the query plan. If your application is actually written in 64-bit, that means that we can actually do that locally without making a request to Cosmos DB. That is very important. If it's in 32-bit or any CPU, when you are actually developing the application, you might not have the required DLL file, which is, I believe, service interrupt.dll file. If you don't have that, that means that you have to request the Cosmos DB to generate the query plan. From here, Cosmos DB is going to look at if the partition key is actually in your where clause. If it is, then that means we know exactly where the data is. We can just make that request and get data from there. If it's not, well, then that's going to probably cost us a lot of request units, which is money. So if you have 20 physical partitions, you're going to run the query in 20 different places. From here, many people kind of get confused is, okay, let's say we have the data. Maybe it's coming from the 2 or 3 physical partitions. And let's say we have order by or aggregation, or we are trying to find a minimum number. Well, you cannot do that in Cosmos DB's database engine because data is all over the place. So some data is coming from here, some is coming from the other place. So we kind of need to take them in the central place so we can order by, or we can do the aggregation, or find the minimum number, which that's the SDK. And database can help, but it cannot do all the work for aggregation, order by, because it has to kind of land in somewhere central, and that's the SDK. So for SDKs, you might need good resources because there's going to be a lot of work SDKs are going to do for Cosmos DB. Next one is the data models. In SQL Server, well, you must know T-SQL to use any of the data models actually SQL Server offers. So we have the relational data model. You can save JSON objects, you can save XML, and graph databases are the latest one, came in 2017. Those are great options, but you must know T-SQL. They don't have their own languages for SQL Server, so you are really depending still on the relational database structure of SQL Server. In Cosmos DB, we have different models, and each different model actually uses their own unique languages. So if you are, for example, using the MongoDB, well, you use the MongoDB's API. You use the MongoDB's language. So you don't have any kind of limitation like, oh, I have to kind of respect SQL Server's kind of structure because they find a way to actually deliver. That doesn't mean that, MongoDB might have many more features that SQL Server might be able, not be able to deliver to you. Same with the Gremlin, Azure Table, Cassandra API, each of them actually use their own languages. When I say own languages, let's say you have a MongoDB application. All you have to do is move your data to Cosmos DB and change your connection string, so your MongoDB API is going to think that it actually is connecting to MongoDB when it's connecting to Cosmos DB. The latest actually addition is the PostgreSQL, which means that Cosmos DB actually supports the relational data models now, which is really kind of confusing and tricky, if you ask me. So, next topic is indexes. There are all kinds of indexes in SQL Server, and they're very useful for many situations. When you create a SQL table, well, SQL Server actually creates that table for you, and usually there's no index on it. So, as a DBA or developer, that is your job to create whatever indexes you need one by one on the table. Indexes are centralized just like your data, and they are in the same place where the data is. If you need to change or create any of those indexes, you usually do one by one. You don't want to go and kind of try to create them in the same time in SQL Server. Cosmos DB, we have a couple of, I guess, different indexes. Range is the most common one, which is for equal, not equal, larger, or less than. That's mostly range indexes in Cosmos DB. And we have composite index, geospatial data index. If you want to do any kind of full text, you can use Azure Cognitive Search. And even if it has a column store, you can actually have a different storage. Since Cosmos DB is an OLTP database, if you need to analyze or do kind of like any data science, you don't want to do it in Cosmos DB. You want to have the analytical storage and do it out there. So that's the column store option. Now, when you create anything in Cosmos DB, not like SQL Server, in Cosmos DB, everything is getting indexed. So you start with a huge index file because of that. Reindexing is free, but there's a catch out there. So if you have to reindex something, let's say your application is using 1,000 request units per second, but probably maybe it's using the 800 of it every second. So you have like 200 left. Cosmos DB will use that 200 to actually complete reindexing, which means that it can take a long time to actually complete the indexes, the reindexing. Each physical partition, as I show you, you might have 20 physical partitions, right? Each of them has their own index files, which means that if you need to, do reindexing, well, you have to send that reindexing to 20 different physical partitions. And because of that, you want to actually create and change all the indexes together, not just like SQL Server. Let me do one first, I will do the second one later. You want to do all the changes together in Cosmos DB. Sure.
Just to clarify, if I have 20 different followers, that means all 20 must be indexed?
Correct.
Okay.
Yep. She was actually asking if we have 20 physical partitions, all of them has to get reindexed, and that is true. Yeah. Next one is the connections. In SQL Server, connections, first we have to do the physical channel. It needs to get established by the network. It needs to get handshake. We have to parse the connection string and authenticate. It needs to get authenticated by the server. And if you are using .NET or any kind of SDK, usually we kind of cache that connection so we don't have to do this again and again for SQL Server. In Cosmos DB, we have different ways to actually connect. Since it's in cloud, things can get really kind of sometimes tricky. So the first one, which is the SDK2 is using by default, is the gateway server. We have the gateway server in the middle, and it's using the HTTPS. That means that you don't have to worry about the firewalls and other stuff that much. So that's why most of the people use the gateway server. So you don't have a direct connection to your physical services, the physical partitions, and everything goes to the gateway server, and gateway server find the data and return back to you. As I said before, you don't need a firewall settings here, but you're actually adding a network hub. So there's a latency a little bit higher here. If you like, actually, you can do a dedicated gateway server. The gateway server is you're getting shared by other actually tenants of Cosmos DB. If you want to have your own gateway server, you can do that too. Because all this, things needs to happen when you try to make the connection, especially in Cosmos DB, it needs to figure out which physical partition has what data, what is your account, what that user can do. There's a lot of requests actually going on, and need to figure out all this stuff when you make a connection. Because of that, you should use singleton for this. So you want to do this only once. Then from that point, just like the polling the connection, use the same connection for different containers in Cosmos DB. That's pretty important because you don't want to make those 3-4 requests every time before you make any kind of query in Cosmos DB. The next one is the direct connection. Direct connection, well, we don't have a gateway server anymore, so that kind of adds more pressure on the SDK because SDK is responsible to figure out and map which physical partition has what data. So in that moment, we don't have that network hop anymore. Things are working much faster, but this is using the TCP, which means that you might need to actually go back your IT department and kind of look at your firewall settings and open ports and be sure everything is working fine. Next one is store procedures, which is very common in SQL Server. Those are, you use the T-SQL for that. They are read and write friendly. They give you better performance because usually they get cached. And you can join the tables just like in other, select statements you are having. In Cosmos DB, things are a little bit different. So you must know JavaScript to actually write store procedures. They are write friendly. They are not read friendly. They can read data, but it's not recommended. The main reason, if you actually think about the physical partition, Cosmos DB store procedures will always execute it on the leader. They will never get executed on the followers. And the leader is usually busy by writing data, deleting data, updating data. So the last thing you want leader to do is reading data. It can do it, but you're going to put too much pressure on it, so you don't have to do that. So if you are going to do any kind of store procedures in Cosmos DB, try to use it only for write rather than read. And every store procedures is specific to a container. So that means that you cannot join to other containers. It has to run only in that specific container you created for. You can actually implement transactions by using the store procedures in Cosmos DB. Triggers is the next one. So those are the special store procedures in SQL Server. We have different type of triggers for DML, DDL, and logon, and they get executed automatically in SQL Server. In Cosmos DB, they are special store procedures. Again, you need to know JavaScript for them, for you to write them. There are two types of triggers, pre-trigger and post-trigger. Pre-trigger, we mostly use that for validating the data. So before you do something, you can actually execute that pre-trigger, and it can check things for you, and if everything goes fine, you can kind of continue. Post-trigger is after the transaction, and those are great. You can check the database item after your transaction. And unlike the SQL Server, those are actually getting executed by you. So you have to actually fire them from the SDK manually. Pricing can be really, tricky in SQL Server. There are many ways to actually, pay to SQL Server. And the last one actually came is the pay-as-you-go rate. So you can actually even do that right now in SQL Server. So I'm not really going to go in details here, but it can be really tricky. And especially if you need to scale up your SQL Server, the pricing can go up since, the licensing usually depends on the core of the CPU. In Cosmos DB, well, everything is actually in request unit. And so 100 request units usually cost you $6 per month. And the minimum you need is 400. So we are talking somewhere between $25 to $30 per month. That's the minimum number. And there are different options. There's, for example, auto scale. So this is great for the provision threshold. If you know exactly what you need, you can go with that, and you can change it anytime. It can go up and down. Or if you don't know what you are actually looking for, you can actually pick the auto scale. Auto scale works like you kind of pick what is the largest request unit that you can afford, and Cosmos DB can scale up and down depending on the traffic automatically. So that's a great option, but that doesn't mean that you have to pick something like that you cannot afford. For example, if you're going to pick 100,000 request units per second, and you might think that you are never going to hit that, you might, because somebody might one day try to attack your application with the DDoS attack or something like that, and you might end up with a really surprising bill. So you want to be sure that you pick a number that you can actually afford. Serverless is the other one. Serverless request units is not per second, so you are going to spend 1 million request units, for example, for 28 cents. So that is great if you have an application, for example, Azure function, and it kind of runs, you don't know when and how much, you don't know. In that case, you can just buy the total request units, and it will just subtract from that, whenever you run the application. And the storage usually is the cheapest, since in Azure, the storage is pretty cheap. For transactional, it's 25 cents per month for 1 gig. Analytical is much cheaper than that, as you can see. Next one is views. Views are pretty common in SQL Server, and those are the virtual tables defined by a query, and you can do them index views, so they can be actually materialized, and you can put some indexes on it, and users likes it because you can run really a complex query and create a view, then you kind of make the query simple for the users. In Cosmos DB, there's nothing like that in views. But you can actually create and materialize views by using some of the different functions of Cosmos DB, like change feed. Change feed is really like a CDC. And for change feed to work, for example, let's say here we have container, and we are saving orders here again, and our partition key is customer ID. Now, we are running this select statement, and we are looking, well, give me all the orders for this product, and we have the product ID. The problem is, well, my partition key is customer ID. So there is no way to run this only in one physical partition. And this problem you see here, we have to send it and run it in every physical partition. And that's going to cost you a lot of money. It's going to be a lot of request units. And this problem here, what you see, if you are running this query, this problem is going to get worse. It's not going to get better, because your data is going to get larger. Your number of physical partitions is going to get more. Then it's going to get, actually, the 49 is going to get higher and higher. The problem in Cosmos DB, you cannot repartition your containers. And if you are running this query many times, you're in trouble. So there are 2 things you can do. The first thing, you can try to get this data and create a new container with a different maybe product ID, and move all your data there, which is a lot of work. And also you might need to go and change your code because your partition key change. Or, as I said before, storage is cheap in Azure, so you can try to tackle with the storage. But what we are going to do here is we can create the change feed function. So when the data comes to the Cosmos DB, the container is the customer ID, partition key. We create a change feed, which is a CDC. It takes this data, whatever is changed, and runs this Azure function that we set up. And Azure function can really do anything from this moment, right? So in this case, we create another container named orders under product. And this Azure function is going to actually replicate whatever the data is changed to a different container. So we end up with the same data, 2 containers with different partition keys. Since storage is cheap, this might be a much better, actually, a solution rather than you try to find a really common partition key for your application. So in this case, well, we have a different container named orders product, and my partition key is different. Now I can actually run this query in only one physical partition, rather than running in every physical partition. So it goes from 49 and 8. So that's a great, actually, save. That's, yeah.
How many change feeds are practical, sensible?
So you will have one change feed for...
I mean, for my system. So I can see how this works, and I see how clever it is, right? But is there a limit to how many of these extra partitions you want to create?
So the question is how many change feed functions we should have. So for me, for me, I mean, that is my opinion, is I would like to have one because I don't want change feed to I have many change feed to trigger. So I'm going to have different Azure functions. And at the end, they're going to get the same exact source change. So I will have one change feed, and maybe an Azure function might have different functions. And depending what that change does, you might need to maybe send that data to Signal R, so it will go maybe in real time on a dashboard, or you might try to write it to a different container with a different partition key. So that's what I will do. That is my opinion. Next one is performance tuning, which can be a challenge in Cosmos DB because there's not really that much documentation on that. In SQL Server, but most of the stuff really applies to SQL Server. So you want to select only what you need. You don't want to go and select all and get all the data. Missing indexes is important. You might want to look at the missing indexes, and you can use the indexing metrics for that. Indexing metrics will actually suggest you if you are missing any indexes on your application. And in SQL Server, we have the query hints. You want to be careful with those. Usually, SQL Server knows the best way to pull the data, so don't try to overwrite that in SQL Server. In Cosmos DB, we don't have anything like that. In Cosmos DB, we have the point read. So point read is very interesting here because in point read, you need to pass the partition key and the document ID. If you have that two numbers, then your query is going to execute it very fast, and it's going to actually cost you only one request units. It's not going to even run the query plan or anything like that because you are really pinpointing to Cosmos DB where the data is. Rather than that, you want to have, you don't want to have many containers. Like in SQL Server, you have many tables, many lookup tables. You join them together. You don't want to do that in Cosmos DB. You want to put your data model together, and you don't want to have, many requests to actually render a page. So you use the execution plans in SQL Server to find the problems, and if you have really large tables, you use partitioning. In Cosmos DB, as I showed you before, try to use the materialized views if you have partition key problems. Use the TTL, so if you have a retention policy, after 2 years you don't care about the data, you can use the TTL, and actually Cosmos DB will delete the data free for you, and the storage will be cheaper because you don't keep all the data in OLTP database. And you can use the execution metrics in Cosmos DB to figure out how long things takes time in the Cosmos DB database engine. Another important topic is null and undefined. So those can be really tricky in any kind of databases. For example, if you are going to look at if it's null is equal to null, in SQL Server that is false. Try to use the is null and is not null functions in SQL Server to handle that problems. And if you're going to use any kind of aggregation like count and average, you want to be sure that you know that the SQL Server is not going to actually count or calculate those null columns or null rows. So that can change the calculation. You want to be careful with those. In Cosmos DB, if you have any null values, you should not keep that in your data model because there's no schema. So if you don't have the address, rather than saying address is null, just take the address out from there. That will save you actual space. In the meantime, if you are going to do any kind of like the system functions or any kind of mathematical expressions, if the system is going to find null, then the value is going to be undefined. So let's say you might have 100 documents and one of them actually has null in it for the, let's say age is null for one user. doesn't matter, you have the 99 is there, it's going to be, the result is going to be undefined in Cosmos DB. And Cosmos DB actually has isNull and isDefined functions too. So you can use that to make any kind of decisions before you run anything in Cosmos DB. Next one, which is a big topic, is data modeling. And in SQL Server, we have the database. Database server is the place that usually, if you need to scale, you kind of scale into that level. And we have tables. Tables can be used for the OLTP or reporting. And usually when you run an application, your model might have tens, sometimes hundreds of tables, which is the best part of the SQL Server because you can make joins, you can change the data model easily. But the problem is, you're going to end up with lookup tables. So if you have a page, let's say, for example, think about the Amazon product page. You are looking at product. How many calls do you think we have to make to actually render that page if we are using the SQL Server? There's going to be a lot. You might have like drop downs. You might going to put the list there. You have reviews. You have all kind of information. So just to render that page, you are going to make a lot of calls to SQL Server, which is fine. Works with the SQL Server. And every table is going to have, hopefully every table is going to have a primary key, and we are going to have columns and rows in each table. And you want to be sure that you use the filtered indexes. You are going to filter by the indexes. In Cosmos DB, things are a little bit different. So first of all, the scaling is not happening in the database server level. It happens in the container level. So if you compare that to SQL Server, that's really table level. So you can easily say that this table is very busy. I can scale up and scale down easily in Cosmos DB. So we don't have tables. We have JSON object in each container. And that's only for OLTP. So if you are going to do any kind of reporting, any kind of data science, you don't want to do that in Cosmos DB's APIs. You want to move your data to analytical storage and do all that in the different location, not in the Cosmos DB's APIs. We have a record ID. I guess we can compare that to primary key of SQL Server, which is those are system-generated data. And rather than that, we are going to have, if we compare the columns and rows, we are going to have JSON properties and objects. So those are the columns and rows we can really compare to SQL Server. So as I said before, in SQL Server, to render a page, you're going to make many calls. In Cosmos DB, you don't want to do that. You want to take your data and try to put it together. And if still you are looking at, for example, the product page of Amazon, hopefully you can actually render that data maybe 1 or 2 requests from the Cosmos DB. If you're going to make more requests to Cosmos DB, that means that probably your data model is wrong. There's some potentials out there you can fix the problem. And you want to make few requests to actually complete what you are trying to do in Cosmos DB. And you want to be sure that you are going to have the partition key whenever you make the request in Cosmos DB. The best one will be you will have the partition key and the document ID. Then that means it's going to be really cheap to actually run your queries in Cosmos DB. So if we compare that, I guess, to daily items in SQL Server, it's really like kind of like a sandwich shop, right? So you have all these tables, and query can actually pick any of those and make the sandwich for the user, whatever they are asking. You can do that dynamically. And it's relational, it's very flexible, and you can join to whatever here, really. And because of that, there's a constant pressure on the query optimizer, because it needs to run all this request from the user. In Cosmos DB, that's not the case. You want to actually be sure that what your customers want from you. So if you are in a place, if you are selling the sandwiches and your users are eating only veggie sandwiches, you want to be sure that most of those sandwiches are veggie sandwiches rather than steak. So in this case, we don't have relations. So you cannot on fly make a sandwich. So you really need to know if that's the product page of Amazon. You know exactly what that page wants. So you want to make your data model just for that request. In that case, you will make less requests because all the page, whatever it needs, is going to be in that data model. We don't have a schema, so you can always add and remove items, and there's no joins. Now, I guess the biggest question is, which one should I pick? So as I said before, it's not an easy to answer. It kind of depends what your requirements are. But when we compare that, it's not really this easy anymore. If you're a relational database, pick SQL Server. If it's non-relational, pick pick Cosmos DB. It's really not that simple anymore because, well, SQL Server actually can handle JSON. It can handle XML. It has the graph database tables. It has memory tables. So it can actually, handle NoSQL depending on your, requirements. But, you really need to pay attention to the, I guess, the limits of SQL Server because that's a scale up. And that means that, you might end up, if your application is going to get really large, you might have problems with the SQL Server. SQL Server is great because it's available on cloud or on-prem. So that's a great option for SQL Server. And if you do, your application is going to do a lot of aggregation, SQL Server is the king with that. You can do all kind of aggregation. You can use it for OLTP or reporting. So that both works for the SQL Server. In Cosmos DB, we really cannot say Cosmos DB is a non-relational database anymore because they just actually start to support PostgreSQL. So you can easily create a PostgreSQL and have a relational data model in Cosmos DB. That means that if your application is going to get really busy, well, there's going to be a high scalability option for you in Cosmos DB. And it's going to be horizontal scaling rather than scaling up. Well, if your application is going to be on cloud, Cosmos DB is in cloud. Cosmos DB born in cloud. So probably it's going to be much easier to pick Cosmos DB because of that. Cosmos DB has multiple consensus levels. So depending what you are trying to do, you can do strong or you can do eventual. And that will actually change the price of each request units. So you have some flexibility out there. And also you have the global distribution with multi-region write in Cosmos DB. So if you're a global company, well, Cosmos DB can be a really good option for you because it handles all kind of replications, all the data distribution just for you in the backend. And you have a lot of great control to actually how that data is getting copied, especially when conflict happens. Conflict happens in anywhere, especially with the global distribution. Now, so as I said before, I show you a lot here. In SQL Server, mostly you know which, I guess, tools you use for execution, plans, and other stuff. That's why I actually created this application here that I want to share with you. It is totally free. It's a VS Code application. And it kind of shows you everything, how Cosmos DB actually works. So you just put your connection string here. It's going to list the databases. After you pick databases, it's going to go to the post. So as you can see, I'm picking the select top 10 here. If you click the partition list, it looks like I have 5 partition lists, right? So as you can see, I have the minimum hash number, maximum hash number here for each of them. And if I'm going to run a simple query like that and execute it, you can actually see all the execution metrics here. You can tell that I am hitting 5 physical partitions because my partition key is not in my where clause. So actually, if you look at it, it will tell you all the details, where they are coming from. As you can see, I say top 10. It's actually getting top 10 from each physical partition. And SDK is the one which displays only 10 of them because, well, in this case, I'm getting 50. And I'm paying for 50, but you are displaying only 10. And as you can see, each of them actually costs this much request units. And rather than that, you can see all kind of numbers here. You will see the indexing policy, which kind of tells you which are indexed, which are excluded. You can do a point read here. I guess we can try this one too. So as you can see, I have the ID number here. Any kind of queries you're going to run, it's going to actually cost you at least 2.5 to 3 request units. But if you actually have, so in this case, post ID is my partition key. And this is the document ID. So if you have, for example, a grid, and under each row, you can actually hide this post ID and the document ID. each time you click that, for example, the row, maybe a window opens and give you details. If you can actually architect your application this way, well, this is going to cost me, as you can see, 1.33 request units. It's much cheaper if you have all the information you need from Cosmos DB. And this is usually one request units, but that really depends the size of the object. So it looks like this object has a lot of text here. So that's why it's costing a little bit more than one request units. But rather than that, you can actually easily go and open the indexing matrix here. So if there's any kind of indexing matrix you need, it will get displayed here. Well, let's try that too. Let's see. This is actually the Stack Overflow. I just put it in Cosmos DB. So I'm kind of running that here. Let's find our owner user ID is 1. If I execute this one, as you can see, it cost me 26.78 because, well, post ID is not there, and I'm hitting 5, as you can see, 5 places. And from here, I can actually go to indexing matrix, and it says that I am using the owner user ID that is getting utilized. That means do not replace this, do not remove it. But if there was any kind of potential indexes, it will actually display it here for you. Rather than that, you know, if you have any geospatial data, you can use that on map. You can actually search by any kind of polygons you can create. And data analyzer kind of, JSON object is not easy to kind of, you know, figure this. For example, in here, I just did, you can analyze it very easily. You don't need a Power BI for this. So for example, you can say, I want to see the score. You can actually see the score here. Actually here, score is the analyze, and timeline option is the ID. As you can see, it kind of gives you what is the average, what is the minimum of score. So it gives you kind of like a simple information about the item property you are looking for. And query analyzer, you can actually use that. If you compare, I guess I can compare it to SSMS. You know, you have that option. I forget the name of it right now. It kind of tracks all the information every time you execute the data. It kind of gives you the timeline. How is it changing with the execution plan? You can do that here too. You can just click start here and execute it. So it's going to actually look at all the data. It's going to give you here. So if you're going to actually go and change this one to 2, for example. So you can kind of see how is it changing with your, this will help you with the performance tuning. So this is free. You can get it from the VS Code. It's right here. You can just search for Savran Web. And you can download it right from the VS Code. And it's available in the marketplace too. You can get it from. But rather than that, that is all I have for you today. I hope everybody learned something new, and that is my, I guess, the evaluation. Please give me feedback. I will be more than happy to kind of learn what you think, and positive or negative, doesn't matter. I'm trying to make my, sessions better every time. So everybody, I hope, learn everything, something new today. Thank you for coming to my session.